Hey guys, we're going to look at our first little taste of the unit circle and going from degree mode to radians. So radians are another unit of measure for angles. So we're very familiar with degrees when it comes to angles, but now we're going to look at radians. So this whole thing right here is a detailed explanation of this unit of measure. So think converting from centimeters to inches. Those are different ways to measure length. This is a different way to measure an angle. So we know a circle is 360 degrees. In radians, we're measuring a whole circle is 2 pi radians. Okay, so you can read through these explanations on these first couple of pages, but what I want you to do is look at example 1 and 2 with me, going from degrees to radians and then radians to degrees. Now there are 2 formulas that are not in the formula booklet that we need to make sure that we have in our memories to go from degrees to radians and radians to degrees. Now this is all about proportionality between the number of degrees in a circle and radians in a circle. So if I compare 360 to 2 pi, that fraction can simplify to 180 over pi. So it's really just a proportion that we're setting up here, but to have this memorized would make things go much faster. And this is the simplified version of the 360 and the 2 pi. It just makes numbers smaller. So if I am starting in degrees and I want to end in radians, this is what I'm going to do, okay? Because I'm going to get an answer in radians. So I'm going to take my degrees. So theta 1 says it's 30 degrees. I'm going to multiply by pi over 180. So basically, I'm going to put this in my calculator. I really want this to be an exact number because most likely I'm about to use it in other things. So I am not going to multiply by pi here. I'm just going to bring it over here. What I am going to simplify is the 30 divided by the 180. So when my calculator simplifies that for me, it's a 1 over 6 times pi. Another way to write that is pi over 6. These mean the same thing. Now, I don't really want that decimal answer. I can write it down and it wouldn't be wrong, but remember this is going to be used again later, so you would not want to use rounded answers to get new answers. Okay, so go ahead and try my theta 2 and my theta 3 for 80 degrees and 27 degrees, and we'll see how you do. Okay, here you go. So the exact answer would be here. If you just absolutely want to put down those decimal answers, remember you would want to copy and paste the whole thing and use it later in the problems. Okay, so the opposite direction would be if I start in radians and I need to get to degrees, and I'm going to multiply by the reciprocal of that because now my proportion is upside down. So let's look at a couple of these. So we have my theta is pi over 3. So I start with radians. So my theta 1 is pi over 3 in radians, and they tell me it's in radians right there, and I need to get to degrees. So I'm going to multiply by 180 over pi. And the way I remember this is I really want the pi's to cancel out. So I really don't even have to put that part in my calculator. I have 180 divided by 3, and that gets me 60 degrees. Here on theta 2, we've got our 4 pi over 9 times the 180 over pi. Again, those pi's are going to end up canceling. So now I can just do 4 times 180 divided by 9. And hopefully we got the same answer as we got above, which is that 80 degrees, because we just went the opposite direction. And then this last one doesn't have a pi with it. So they've got this rounded answer already for me. So 2 radians is still going to move to degrees. I'm going to do 180 over pi, but this time there's not a pi to cancel. So if I wanted the exact, I could technically leave it as the 360 divided by pi. But in degrees, that doesn't really make sense for me to say 360 divided by pi degrees. So I would really probably want to say the approximate value for that is 114.592, lots of decimals, degrees. on that one. So that would probably be the one example that I would say that really doesn't make sense in my head to say that that's degrees. Okay, so let's keep going. So we've done arc length and area of sector in degrees. Now we have the formulas that go with radians, and these are also in the formula booklet. You just have to know how to use them. So if I'm given a problem and my angle is in radians, these are the formulas that are appropriate. My other examples had my angle in degrees, so those would be the formulas I would use. Again, it's just following formulas. So arc length is theta times r. Well, theta is the angle in radians, so I'm just going to do 0.6 times 5. Put it in my calculator and I get 3. So this arc length right here is a length of 3. Area of sector, again, it's just a formula, so 1/2 theta times r squared. Again, in this formula, theta needs to be in radians, so I'm going to do 1/2 times 0.6 times radius squared. Radius is 5, so 5 squared. I put that in my calculator, and I get the area of the sector, which is 7.5. So that's the area of this pizza piece, pie piece, whatever you want to call it. And then the last one is the perimeter of the sector. So perimeter is all around this. So I already know this arc length. I just need to add on these two. And we know that these are the radius. So we have a radius plus another radius plus my arc length. So that really is just 5 plus the 3 that I already found in that first part. So 13 would be the perimeter of that. Last one, example number 4. They want me to find the area of the segment. And that's the shaded part right here. We call that a segment. And really what's happening visually is I'm going to do the area of my sector minus the area of my triangle. So if you look, the sector is this whole pie piece right here. If I take away the area of the triangle, I'm left with just that shaded original part that I did the squiggly in. So area of sector is the 1/2 theta r squared that we just talked about, minus the area of triangle. So if I had base and height that were perpendicular to each other, I could use 1/2 base times height, but that I do not have. So this right here, it says my theta is pi over 3. They gave me that right there. So I'm going to use my 1/2 AB sine of C formula that we learned before. So I'm going to put everything where it belongs. I'm going to show the setup. 1/2 theta is the pi over 3, and that's in radians, just like it needs to be. R is 9, so 9 squared, minus my area of triangle, 1/2 AB sine of C. Remember, this needs to be side, angle, side. My C needs to be this middle angle right here. My sides are the ones on each side. Well, this is also a radius, so that's 9 right there. So I'm going to have 1/2 9 times 9 times sine of pi over 3. Now this is where we need to be careful. If you are doing a trig function, plus you are in radians, okay? Trig functions and radians at the same time, you have to change your calculator mode. Change calculator mode. You have to go into radians. So you can tell at the top of your calculator, it says degree normally for us. If you're doing trig functions and you're working in radians, you have to change your mode. This is the only time, is if you have those two things together, trig and radians. Okay, so when I do that, I can go ahead and put every bit of this in the calculator all at once. So go ahead and do that. And when you do, you should get 7.33747, lots of decimals, and you could round to 3 significant figures.